welcome to Algebra II with Mr. Clausen. Today I am starting a new unit on trigonometric functions, and specifically we're going to talk about exploring periodic data today. And to get started, I want to look at how we can identify what a periodic function is. We'll look at how to identify the number of cycles present in a coordinate grid, the number of the period of a periodic function, as well as their amplitude, and then we'll finish off by talking about how we can draw periodic functions. So without further ado, we will move forward here. And the first thing I want to do is talking about how we identify a periodic function. And the main thing that I am looking for if I am trying to identify if something's a periodic function is I'm looking to see if a pattern repeats itself. So for example, if I'm going and I'm looking at a function like this and I see, hey, like it starts here and it ends here, I see that as I go along this function that it goes and it ends up at a spot where it repeats itself. And if I were to physically take this line and move it around, I could see that this pattern repeats itself over and over again. So I may look for a spot where it crosses the x-axis. I might go and say, oh, if I go from peak to peak, does it repeat itself, and those type of things, and see if something is a function or not. And in this given case, I see that this given graph is a function, a periodic function. I also see that the one below me here is also a periodic function. I see that as I go from 0 to about 3.1 or 2, somewhere in there, I see that this pattern occurs and then this pattern repeats. And that we just see the same pattern over and over and over again. And so this would be very indicative of a periodic function. Now, things you have to watch for that may look a little periodic, but may not necessarily be periodic functions. And that would be examples on this side. And so, and a big thing that I look for, with periodic functions, a lot of times I'll look from peak to peak. I'll go, all right, if I see like this, I see, oh, this looks like a periodic cycle here. And then it's like, oh, it does it again, and it does it again. And a lot of times I'll just go from peak to peak and see like how far apart that they are. But in this given case, one of the things that I'm gonna notice here is that, oh, it just keeps getting higher and higher. Okay, so if you can't base a single line, a single horizontal line that you can base all of your functions are on based on a periodic point, it is not a periodic function. You see that with an example like this. Let's say if I was basing it off the minimums here, if I have a line going across the x-axis here, I see that as soon as this function touches the line, the periodic function starts over. And that's very key when we're looking at this. In this given situation, this is not a periodic function. This is not a periodic function. And so we have to be mindful in looking for this. And the same type of thing here. I can go and I can say, oh, like it has the same pattern going both ways, but it's not periodic. It's not the same pattern over and over again. And that's what is very key to keep in mind, is that, if it's not a repeating function, it's not a periodic function. So with that said, let's talk about how we can identify things like cycles, periods, and amplitudes and that type of thing. So an amplitude, as I have in my diagram here, is just the height from the midpoint to either the upper peak or the lower peak. All right, and so if you ever want to know the total height of a periodic function, you just take the amplitude and you multiply it by 2. Or you take the total height and you divide it by 2 if you want to know the amplitude. And the period is just the distance that it is from one point in the periodic function to the point where it repeats. All right, and you can pick various points when you're looking at and trying to compare this. So for example, I can tell you that this function up here is a periodic function. And so let's say I base it off going maximum to maximum, and I want to see how long it takes for me to go from one point in this periodic function to a point where it starts over. So I go and I see, all right, it goes down, it comes back up, right? That's one function. And then if I draw that exact same shape again, it goes down and it goes back up. And I see that from the point where it starts 0 to the point where it starts over again has a delta x of 1. And this is going to be what your period is, right? And your period is the length for one cycle to occur. So if I go and I look at this function, I can go and say something like, oh, all right, so if I go from here to here, that's a cycle. 2 cycles, 3 cycles, 4 cycles, 5 cycles, 6, 7. Oh, and there's a little bit on each side. So this periodic function has 9 cycles present in the entire thing. And a lot of times if I want to know the number of cycles, I want to know the number of cycles from like a point like 0 to 2 pi, for example. And we'll talk about that in a little bit more detail in a later video. But that's a lot of times what I'm looking for in terms of cycles. Cycles are just asking how many periods there are at a given set or a given viewpoint. Okay, and then if we want to know the amplitude, okay, what I'm going to do is I'm going to find the midpoint between this. So I see this goes from 0 to 3. Okay, so that is the total height of my periodic function. So the midpoint of this is going to be at 1.5. The midpoint of this is going to be at 1.5. So that means that the amplitude for this given periodic function is just simply 1.5. Okay. So the amplitude is equal to 1.5, and the period is equal to 1. And I'm going to do the same thing down here. I'm just going to look at the function. I'm going to see how long, where the repeating patterns are. So I'm looking, all right, if I base it off the x-axis, I can go, all right, this is a distance of 2. If you want to base it off the maximums, you can totally do that. So if I want to go, all right, how long does it take for this cycle to complete? What you're going to find is that the distance is always going to be 2 if this is a periodic function. What if I want to base it off the minimums? How long does it take to go from minimum to minimum? Well, it takes a total of 2 units for this to occur. Okay, so whenever you're trying to identify the period, it doesn't matter what point you pick to what point. You just have to identify, oh, where's a point where a portion of this periodic function starts and then restarts. All right, and so based on this analysis, I can see that this has a period of 2. And for this first lesson in this unit, I just want you to look at some graphs. I want you to go and I want you to identify the period, whether you're basing it off the minimums, the maximums, or maybe where it crosses the x-axis, and look at that. Just be careful that you're not doing just half of a function. So you have to be crossing the x-axis and going in the same direction. And then I also want you to be able to find stuff like amplitude. So I see that the x-axis is the midline, and I see it goes up 1/2 and goes down 1/2. So the amplitude in this given situation would simply be 1/2. And I would just simply see that the amplitude is equal to 1/2. And so that gives us a nice baseline as far as trying to figure out, you know, where that value is. And if you're still a little unsure, like, oh, how do I find the amplitude of a given function? The amplitude could be summarized in an equation like this, where the amplitude is equal to 1/2 times the max value minus the minimum value, right? And if you see in this case, 3 minus 0 times 1/2, 1.5 is the amplitude. 1/2 minus 1/2 would equal 1. 1/2 of 1 is 1/2. And that's another way that you can find an amplitude for a given periodic function. Okay, so hopefully some relatively basic information that you can use to go and just identify some periodic functions and find some information like the period of it and the amplitude of it. So the third skill I want to move on here with is talking about how to draw a periodic function. So a big thing that I want to point out here is that if we want to draw a sound wave with a period of 0.02 seconds and an amplitude of 4, the first thing I'm going to do is I'm just going to go and identify here, that this is 1, 2, 3, 4, 5, and this is 1, 2, 3, 4, -5. And let's say, for example, that this point here is 0.02 and this point here is 0.04. And all I'm going to do is I'm going to put a tick mark at every 0.02 seconds because this represents our period. That's how often that this pattern is going to go and repeat itself. And so with this just gives me some easy points to base off of, and then I see that the amplitude is 4. So remember, if I want to use the x-axis as my point here, then all I'm going to do is I'm just going to say, all right, I know I need to go up 4 in terms of our amplitude, and then we need to be able to go down 4 in terms of our amplitude. All right, so the total height is going to be 8. All right, it's going to go have a maximum at 4 and a minimum at -4. All right, so it just gives you a basic idea. And so what I'm going to do here is, so with that said, I know, all right, I got to be able to go up to there, and I'm going to be able to go down to there in terms of my function. And I'm going to write this like a typical sine function. So for example, I'll go up, I'll hit my maximum amplitude, I'll go back down, I'll go and hit my minimum amplitude, and come back up, and go and hit my maximum amplitude, go back down, hit my minimum amplitude, and come back up. And keep in mind that you'll always cross, if it's a normal sine function, right in the middle. All right, and your maximum and your minimums will be 1/4 and 3/4 of the way, respectively. And so if I want to complete this, I want to go the other way, go and draw my function. I'm going to see. And what you should notice is that this up, down, and up, that same shape repeats. If I could just copy and paste this and go over and over again, I would. All right, and so we can just go back and forth. All right, and draw it back and forth. And here you have this periodic function repeating the same shape, relatively, every 0.02 seconds with an amplitude of 4, which just really describes the intensity of the given function. So with that said, I hope that you found this video useful, and let's do some math.